Okay, AP kids, we're going to show you how to balance an equation. And this is what I like to call parallel style. This is my own style of balancing reactions. What you're going to do is start from the reactant side and work your way towards the product side. And what you're going to do is consider all the atoms that are present in the equation and list them. So we got phosphorus, we got oxygen, we got hydrogen, and you'll notice oxygen appears again. We don't have to account for it because we already did. So phosphorus, oxygen, hydrogen, and oxygen again. The next thing we're going to do is account for how many of each of these atoms we have. Phosphorus, we have 4. Oxygen, you have to be really careful about oxygen. You're going to notice that oxygen appears in every single formula in this reaction. And when it appears in so many different formulas, you have to count it from all the sources that it's present in. So we have 10 and 1, which is 11, and hydrogen is 2. Now what you're going to do is on the product side, in the same order, even though they don't appear in that order, is document those atoms once again: phosphorus, oxygen, and hydrogen. Remember, all of the reactions have to follow the law of conservation of matter or mass, which means matter cannot be created, it cannot be destroyed, it's got to be conserved. So what we're going to do now is tally up how many of each of these atoms we have on the product side. Phosphorus, there's only 1. Oxygen, there's 4. And hydrogen, there's of course 3. What you want to do is you want to make sure that you have the same types and same quantities of those atom types on both sides of the arrow. So we got tetraphosphorus decaoxide reacts with water to form phosphoric acid. All right, what you're going to do is pick your battles wisely. The only thing that you're allowed to change in these reactions or alter is a coefficient. And just like in math class, the coefficient is the number that appears in front of the reactants and, of course, the product. So since we have 4 phosphorus atoms on the reactant side, it'd be really great to have 4 on the product side. So what we're going to do is put a 4 in front of the phosphoric acid. That 4 alters the quantity of every single atom that appears in that formula. So what we have to do now is retally. So phosphorus becomes 4. Oxygen is 4 times 4, which is 16. And hydrogen is 4 times 3, which is 12. Now we're going to continue the battle. What should we balance next? I'm going to tell you what you don't want to balance. Atoms like oxygen that appear in every single reactant and product. There's no way you're going to be able to balance those. You're just going to keep going around in a circle. If you balance everything else correctly, atoms like oxygen work themselves out. And you'll see what I mean by that when we continue with this. All right. So since we have 12 hydrogens on the product side, it would be really cool to have 12 hydrogens on the reactant side. And we'll do that. So we're going to put a 6 in front of H2O. When we do that, we're going to end up with 12 hydrogens. And we now have to recount the oxygens. We have 10 plus 6. See that? Worked itself out. We now have a balanced reaction. We're done. So according to this equation, 1 molecule of tetraphosphorus decaoxide is going to need 6 molecules of water to react to form 4 molecules of phosphoric acid. So the balanced equation is as you see it now: 1, 6, and 4. Done. And I'm going to add to it.